Hello folks, we come to the new chapter 10 straight lines, and this is a part 1 video where I hope you have got familiarized with the slope, etc., all those concepts. We have this first question which says that you should be finding out, you should have to draw a quadrilateral which is given like this, and you also have to find out the area. So for that we are going to use all the concepts that we've studied previous year and so on. So let's start right away. When we are doing it in the class, we should be doing it in the graph paper so that we have the coordinates done well. Otherwise, we draw the coordinate system as we always draw, but draw it properly, right? So we'll quickly go in for the drawing of that coordinate system. Let's have the coordinate axis. Yes, quickly the coordinate axis. Let's have the coordinates there. Yes, this is your x-axis and this is your y-axis, and here it's origin, here it's 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, we're making the coordinates, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1, negative 2, negative 3, negative 5, negative 6, negative 7, and so on. Let's take the first coordinate, minus 4 and 5. Yes, presumably here this is minus 4, 5. Then we have 0, 7. Then we have 5 minus 5, which is deep down here. Yeah, it's 5 minus 5. Then we have minus 4 minus 2. So minus 4 minus 2 is a point over here. Right, so quickly we join it and we get the quadrilateral. So let's have the quadrilateral drawn. Right, now it is for us to find out the area of this quadrilateral. That's the next part of the question, and since we only know to find the area of the triangle by using the ideas that we studied in the 10th standard, we are going to draw a diagonal. You can have either of the diagonals drawn and take the two triangles, get the areas and add it up. That's how we are going to, so probably any one diagonal. Let's have it drawn like this. So you could call this as your triangle 1 and this is triangle 2 if you want. Area of triangle 1, we could call it as A1. Half times, I hope you remember, half times x1 into y1, y2 minus y3 and so on, like that. So if you call this as x1, this is the first one, x1 y1, x2 y2, x3 y3. So that is first term minus 4, then you will have 7 plus 5, then you'll go to x2, so that is 0, so that you did not take. Then x3 we will take 5. So when you take 5, we will have y1, that is 5 minus 7. So let's see now how much this is coming. This is half times, this is 12, that's minus 48, and this is minus 2, and so that's minus 10. So that means it is coming to minus 58 by 2, which is, of course we take only the modulus, we're not bothered about the sign. It will be 29.5 if I'm not mistaken. 29.5. Now area of triangle 2. Same way, A2, it's half times, let's have it here, half of, so already x1 and x3 is there, so we'll call this as x2 y2. x1 times, that means minus 4 times y2, that is minus 2 plus 5 because of the minus sign, then minus 4, and then minus 5 minus 5, then the last one x3, that's 5, and 5 we will have y1, that means 5 plus 2. Let's see how this is coming. It is half times minus 4 into 3, then minus 4 minus 10 plus 40, then this is 7. I don't know whether it's 5 minus 12. Why didn't I write it properly? Once again we should check this. x3 is 5 and this is 5 minus 5 plus 2. It's plus 2, so 7 and 5, 35. So 35 minus 12. So this is 75 minus 12. How much will that come to? 75 minus 12 will come to 3, and 7 and 1, it is 63 by 2. So how much is 63 by 2? It is 31.5, right? So the required area of the quadrilateral, is this A1 and A2 together, which we are getting as 29.5 in the first case, and in the next case 31.5. Oh, yeah, this is just 29 because it's 29 and this is 31.5, so that will come to 0.5, 9 and 1, 10, 1 carry, 5 and 1, 6, 60.5 unit square. Since we have done it, if you are doing it in your graph, it will be centimeter square, but here it is 60.5 unit square. Now, I hope it's considered that because it's the area, we will always consider the modulus value. That's why we have taken the 29 out and so on. So this is how we get the 8. Now we will come back to the second problem, borrowed some place from there. They say that there is an equilateral triangle with its base on the y-axis whose base is 2a. You have to find out the vertices of this equilateral triangle. Now that also we can understand it better when we have the picture about it. It's like you have this equilateral triangle. It is having its base on the y-axis, such that the midpoint is the origin or something, do they say? The midpoint is the origin. So automatically this part will be A, this part will be A. That's how they get it. That's how you get the equilateral triangle. Right. Now this is your equilateral triangle, that required equilateral triangle. Right. Now the base is 2A, means every side has to be 2A, right? Because it's an equilateral triangle, and this forms to be the altitude. So you can get what is the altitude. So therefore altitude of the equilateral triangle, what is that? It is root 3 by 2 into side, we have learnt. So that means it is root 3 by 2 into side is 2A, which means it is root 3A. So that means this length is root 3A. If that is the case, you can get this coordinate, isn't it? Once you know the length, you can always get the coordinate. It is root 3A, 0. So now we'll do one thing. We will do a naming ceremony for this triangle so that it's easy for us to plot the vertices. So we'll say that let triangle ABC be as shown in the figure. Be as shown in the figure. This is a naming ceremony for this triangle so that it becomes easy for us. So therefore the coordinates of A. It's clear from the figure that it is root 3A, 0. How about the coordinate of B? Again clear from the figure. On the y-axis it is A there. So coordinate of B is going to be 0, A because it's on the y-axis. Then coordinate of C is 0, minus A because it's going deep down in the y-axis, right? So that's about it. and that's the idea about it. Once you get this, all the other things is very clear from the figure that this is how the things go. This is your x-axis, your y-axis given. Okay, so that's about our problem number 2. Now problem number 3 says that there is a point P with coordinates x1, y1 and point Q with coordinates x2, y2. You have to find out the distance between them in two cases. In the first case, this PQ is parallel to the y-axis. So that means it should be something like this. It is like this. This is your P and this is your Q. It could be anywhere. If this is the case, you have to find out the distance between P and Q. Now, since we are doing too much of the slope, we are going to use the slope concept and get across with this. See, because PQ is parallel to the y-axis, so slope of PQ will be equal to slope of y-axis, always like that, right? And y-axis has got infinite slope, it's undefined, right? And slope of PQ by formula we know it is y2 minus y1 by x2 minus x1. Now this expression, if it has to become infinite or undefined, it will happen only if the denominator becomes 0. Otherwise it will not happen. So that means the denominator is becoming 0. So that means, it implies that the denominator is becoming 0, which means that x1 equal to x2. So when we find the distance, therefore distance, let's see, by formula we know x2 minus x1 the whole squared plus y2 minus y1 the whole squared, x2 minus x1 the whole squared plus y2 minus y1 the whole squared. These both are equal, so it will become 0. So what are we left with? y2 minus y1 the whole squared, which is just y2 minus y1 in modulus form. Sometimes you can have one big, one small, whatever it is, you have to take the modulus of it. That's the first part. Second part also goes almost identical to that. You have the x-axis, you have the y-axis, you have this xy which is parallel to the x-axis, right? You have this p which is x1, y1, and you have this q which is x2, y2. It is parallel to the x-axis. Same idea, slope of PQ will be equal to slope of x-axis, and x-axis the slope is 0. So it's like same thing, y2 minus y1 by x2 minus x1 is 0. A thing becomes 0 when the numerator is 0. So therefore you will have y2 minus y1 is 0, making y1 equal to y2. Now again, to find out the distance, like what we did before, in the distance formula, the same formula, you will have x2 minus x1 the whole squared only as a surviving term. The remaining y1 minus y2 is becoming 0 because they are equal. So what will happen? This will become modulus of x2 minus x1, x1 minus x2. Whatever is the thing, you will only find out the value. That will be the distance. And that is about this problem. With the remaining problems, we'll meet in the next video. Thank you.